In this video, we are going to explore how to use linear regression in forecasting. And I want to emphasize that this is simple linear regression. We have different types of regression, including multiple, but this one is very specific. So let's take a look at what exactly it is. And in other videos, we talk about how to calculate it if you want to, but you don't have to, necessarily, because Excel gives you some really easy tools. But we're going to understand how to use it, and more importantly, how to use it in the context of forecasting. So let's just quickly take a look at what the function is, what the formula is that comes out for linear regression. And remember, I'll show you a graph in a second. Regression is simply a trend line. It can be referred to as that. They mean both the same things, and I'll show you on the graph in a second. But this is typically the function that is displayed to us that helps us to solve different points that may not be predicted yet. Don't worry about that. Let's just look at the formula for a second. So y in our formula, y is simply the value on our y-axis. So if you're looking to find out, and this is most often how we use this formula, we're trying to find out, hey, for a given point of x, in terms of maybe time, which is pretty typical, what is the value of y? Again, we'll look at that in a second. The only things that aside from y and x that are on here, and I'll skip x for a second, there's two variables, or there's two functions that we need to know here. One of them is the y-intercept value, and Excel has a great little function that you don't even need to do this to figure it out. And the other one is slope, okay? So this video assumes that you're somewhat familiar with the idea behind regression and seeing this formula, but now we're going to look at how to use this formula, okay? And then the independent variable, which is the x value. So remember, you've got your y value, which is the y-axis value, and your x value along the x-axis value, or typically your horizontal. And then you've got two other elements here. One of them is y-intercept, and the other one is slope, okay? Just to cheer you up a little bit, it is okay to see these expressions set up different ways. So it's common to see the one in the top left here, y equals mx plus b, or you may see y equals a plus bx. Guys, don't worry about it. They mean mathematically the same thing. It's just mathematicians sometimes have a preference for displaying their functions, and algebraically, some would prefer y equals mx plus b, and then some would prefer y equals a plus bx. They both mean the same thing, okay? So let's take a look at what it actually is, and maybe this will help from a concept perspective. So on this slide, what I've got is simply some historical for a number of periods. These could be years that we're talking about. They could be months. They could be quarters. It doesn't matter. We've got 10 periods, and we've got sales data for those 10 periods. And I've highlighted periods 11, 12, 13, and 14 here. These are the ones we're trying to forecast. So we can do this very easily, or we can do this, a little bit longer way. Both ways work. It doesn't matter. The goal of this video is, once you have the formula, how do you use the formula to forecast? Because quite often you're not going to graph something like what I've done here. Quite often you're just going to come into the Excel, get your formula, do a regression analysis, and determine what in that model of forecasting regression gives you as a prediction for any future months. Okay, here we go. So what we have is I've graphed it, and again, this makes it a little bit more visual. And remember, all that regression is a trend. So we would expect, even before I turn this function on in Excel, we would expect, as you can see, that there's been some upward trend. It goes down a little bit, but it goes up, goes down a little bit, but it goes up. Generally speaking, this is on an upward trend, meaning I've got my months or periods or years, whatever they are, across the x-axis down here. And I've got the value in terms of number of units. It could be money, it doesn't matter. Whatever that y variable is, let's just say it's units, I've got that plotted along the y-axis. We see an upward trend. That means over time, there are more units being bought, as a general trend, if you're just to look at the whole thing. So Excel gives us some really neat functions. In Excel, we can simply add a chart element here. Okay, so when we go to our format tab or chart design tab rather in Excel, we can ask it to do a trend line for us. So it is quite simply add this as a chart element. And for this example, we're going to choose linear. I'm not going to choose exponential or anything that's parabolic or anything at all. So we're just going to keep it straight. Now, a linear regression line, guys, it's always straight. It's always perfectly straight. It's simple that way. Okay, let's change this color so that it stands out a little bit more from our others. Maybe we'll make it a blue and we'll increase it a little bit. There we go. Okay. So there is our trend line. So that's consistent. If you were to stand back and look at the data before I turn that trend line on, it quite simply, you would go, yeah, it's upward. So the forecast for these months, 11, 12, 13, 14, 15, are probably going to be above what they were previously, just understanding the general trend. Okay, so that makes sense. The other thing that Excel allows you to do is on it, you can actually display the equation, okay, which is that same format. Let me just drag it. I clicked that on, so I'm going to drag it over here. I'm going to make it a little bit bigger so we can see it a little bit easier. Let's make that 20. Okay, so there is a formula. So y equals 5.9212x plus 31.933. Guys, that is the same format. Let me flip back here as y equals a plus bx. It's stated with the bx, so it's stated in this format, y equals mx plus b, but it's the same thing, okay? So what do they mean? Remember, we have one number that is not attached to our x value, and that number is the y-intercept. We'll go back in a second. The number that's always attached to our x value is the slope. Okay, and slope is simply rise over run. How far do we go up when we go over one increment? Quite simple, okay? So in this example, we have a number that is attached to our x. So the number that is attached to our x variable in this equation is always slope. It means that every time I go over 1 unit, how much do I go up? I go over 1 unit, how much do I go up? So what this is saying is that generally, every time you go up 1 unit, on average, you're going to go up almost 6 units. So you can kind of make a prediction, say, hey, when I get here, it's probably going to be around that 96 range. You could do that, but we can do it much more intelligently. We can just use the equation to solve the problem for us. But let's take a look at the other parts of the equation. This 31.93, what is that? Well, that is what we call the y-intercept. So this line, you'll notice it's not actually touching our y-axis here. But if I was to extend this dotted line all the way over until it touches the y-axis, it would touch the y-axis at exactly 31.933. So that's called the y-intercept. Once you have those two values, you will know exactly, and you can figure out any period in time independent of the others, okay? So let's apply this formula. If I wanted to find out y, which is the number of units, all I have to do is apply this formula. So let's take example number 11. So it's period number 11. I'm over here. So on my x-axis, I am 11. So quite simply, what I'm going to do is, I'll write it down here. So in this case, y, which is the number of units, let's just say, is equal to, so my slope is 5.9212, and then my x value in this case is period 11, because I want to know what, in period 11, what this number is going to be. And then I'm going to add my y-intercept, 31.933. So let me turn that off. Okay, sorry about that. Always something going on. 31.933. Okay, so that's what the actual formula is going to look like. So let's solve this. So our prediction in terms of the number of units in period 11 is equal to 5.9212 times 11. And then I'm going to add in 31.933. So before I push enter, all I've done is I've taken this formula and I've plunked in some values here. I just want to know x at 11. So I want to know x in period 11. So equals, oops, yes. Okay, so 97, so this equals, I'm going to take this up here. So this equals, oops, 97 units. So our forecast for period 11 using linear regression is going to be 97 units. And you don't need to fill in all of the numbers in between. If you just want to know, hey, what's my forecast in period 15, we can do that. We're going to use this exact formula. We're going to do the same thing up here. So the value of y is equal to, so the number of units in period 15 all the way over here is simply equal to, we're going to use that same equation up there, 5.9212, and x is, in this case, 15, rather, period 15. And we're going to add in our y-intercept, which is 31.933. 31.933. Okay? And that equals 120. So it means that this little number here is actually 120. And if you were to scroll across, you can see it's almost exactly 120. Okay? So just having the formula, you can solve a future forecast using simple linear regression. Just to add to it, another way to think about it, right, is that this is a straight line. And we know that every time we're adding 5.9 units for every time we go over 1 in x. The reason why the y-intercept is important is because it gives us the starting point, okay? So we are starting at 0, okay? So 0 is equal to 31.93. So really, your first period forecast using this model under linear regression is equal to your y-intercept and your slope added together. So watch this, 31.933 is the y-intercept. And then we add in our slope, which is 5.9212. Okay, so that would say that our forecast is 37.85 units. Even though we know what our average was, the linear regression forecast says that, hey, in period 1, that was your forecast. Because the linear regression formula, because it's consistent, simply adds 5.92 units every time you go over 1 in x. So we don't even have to fill out the formula. Another way you could do it is doing it longhand like this. As soon as you find out what your first period is, just add the slope every time. So 5.9212 units. And I can copy that formula all the way down, right? All the way down. And look at the numbers as I get here. They're exactly the same, right? These two numbers are exactly the same. All we've done is figured it out independently for that particular one. But it's really that every time you go over in a period, you're going to add the value of the slope, which is rise over 1. You know, how many units do you go up for every one you go over, okay? Understanding how to use the formula is key, because quite often, all you need is this formula. And there are some shortcuts to get it. You don't need to graph it. You don't even need to, do any of this. You can simply use the native functions in Excel. So we know that the formula requires us to have 2 things we don't have. It requires slope, and it also requires the y-intercept. Now the formula for slope is simply slope, right? So in Excel, slope is simply slope. We're going to add in all of our known y's, okay? So we know, here's our known y's. Let's just take these amounts, okay? And we're going to add in our known x's, which is our 10 periods. Oops. Our 10 periods. And there you go. It's going to tell us, without even having to do this, that our slope is 5.921212 repeating, right? So that's that part of our formula. Our y-intercept is simply intercept in Excel. Okay, and I think that we've gone over this before, and it's the same thing. It's going to ask you for the same values. Okay, what are your y values? And then what are your known y values? And then what are your known x values? And ta-da. Okay, so now you can you can delete this whole table. You don't even need this. You could have figured all of this out with just having these two numbers right here, because we know that y is equal to, now it doesn't matter which way you put this, mx plus b, small b, sorry, or you can state it as y equals a plus bx. It's the same thing. It's the same formula, okay? To solve it, again, all we would do is I'm looking to find out my y value. And when I graphed it, these would be my y values, right? Your time is typically your x value, your consistent one. So every time we go over an x, we're going to add 5.92. So again, our y value is equal to, in this case, we have our slope. So I'm going to do slope times period 11. And we're going to add in there our y-intercepts. And guess what? 97. So, I mean, we come to the exact same values that we did when we displayed the graph and we did the whole thing, okay? The important piece to this whole linear regression is that quite often you're just given this formula. And as long as you have the A and the B values, you can figure out X and Y. All you just choose your period X and it will give you your Y. Or if you want to know in what period you're going to hit a certain number of units, you simply leave the X blank and you solve the equation that way. Okay, so guys, hopefully that gives you an indication about how to use the regression formula. I think it's more important than calculating. We don't typically go through the long form of calculating regression because you have to calculate slope and you have to calculate y-intercept, and doing that manually takes a while. We have some great functions in Excel that can simply do that for us. Okay. Good luck and happy practicing with linear regression.